Hello. I was recently working on this. It's a Philips N1702, which is the rarer of the two models that Philips made that works on these long play tapes. So this can record up to 3 hours in this machine. And in our first episode, we went from it being just a pile of junk that didn't do anything to playing tapes. But we have a problem. Actually, several. Firstly, it's though I can get it to lace up and play, I can't get it to stop. It won't unlace. We can just demonstrate that. I switch it on and you can hear the machine's spinning up and running. And if I press the off button or the eject button on the top, it's just not giving me the tape back. So that's wrong. That's the fundamental fault we need to fix. The clock doesn't work either, and we need to fit audio video output sockets, and there's a video amplifier board we need to install. I keep these blank PCBs in stock, and they're useful for N1502, N1700, N1702 and the Grundig SVR-4004 machines that all tend to have just a modulator output and no composite video outputs. So we'll fit that later when we get it fully working. So at the end of the last video, if you watch to the very end, you'll see that I was thinking that there was a relay stuck on, and I still believe that. There are actually two relays in this bottom board. RE101 sets whether it's going to lace or unlace, and then some switches actuate the motors so that it can do the travel and stop at the end of the travel. So I want to see if that relay is permanently engaged, if the coil on RE101 is permanently engaged. So let's investigate that. If it is, then I need to look at the circuitry that's driving it and the various inputs to that. If it isn't, maybe the relay's stuck in some way, we'll have to investigate some more. So the first measurement I'm going to make is across the relay's coil input, which I think is on pins 13 and 14. Okay, here is RE101 and there is RE102, which is not what we're looking at the moment. So let's just see, it doesn't matter about polarity, if we have energy across the coil when the machine is powered up, and if that goes away when I press the off button. Well, it should go away anyway. Oh look, it's 12 volts. Yeah, and I can't stop it. So that looks right. The relay is permanently engaged. Now the relay is operated by a transistor, which is itself operated by a flip-flop circuit. So let's have a look at the base of that transistor. It's just an NPN. So there's an NPN transistor and it says 0.8 volts there. So that's when the relay is energized. So that means presumably that's true, that we will see that 0.8 volts on the base of that transistor. But we're trying to make it go away. So there is our transistor. There's our base there in the middle. European transistors tend to have the base in the middle. Japanese tend to have them at one end. Right, so let's look at what voltage we see on the base. Okay, 0.88 volts. So that's why the transistor's on. So let's look at the base circuit. Presumably then it's being driven from this IC, the flip-flop. Presumably the output to that is high. But let's just check a few other signals first. Let's have a look at the output of the flip-flop, which is on pin 15. Presumably that's high. Not sure what voltage that would be. 12 volts probably. It's a CMOS. Everything has a 12 volts, so it's probably on 12 volts. Okay, let's look at the output from that IC. It's low, pretty low. And staying there. So something else is forcing that transistor on. Let's look at the logic. So there's a resistor R171. So presumably the output from that is also low. Well, 0.6 of a volt. But that's not as high as 0.8 of a volt. So it's getting voltage from somewhere else. We have R140 going to the base of the transistor. And yet that's at 0.8 volts. Almost 0.9. So where's it getting its voltage from? Where else could it get it from? Well, we need to find R139 2.2K Is that being pulled high? Let's find that one. Because R139 goes to pins, it says 7.5, so that's connector 7, pin 5, which is here. 1, 2, 3, 4, 5. So is that high? Let's look at 7.5. Not sure where that goes. Let's investigate if that's high. No. No, that's not where our voltage is coming from. Well, that's just illogical. So I'm going to desolder the base of that transistor and see if we can find out where it's getting its mysterious voltage from. When I desolder the base, what should happen is the transistor switches off and the machine should unlace. Okay, I've desoldered the transistor, so what should happen when I switch it on now is you should hear it go clunk and switch off. If I don't see that, well, why is the transistor still on? So here goes. That's what should happen. Right, so it's now unlaced properly. Okay, so why is that transistor being held on? The transistor itself isn't faulty, because when we took away the base circuit, the transistor switched off and the system unlaced as it should. So what's the voltage now on the base circuit with the transistor removed? Let's have a look. 3.3 volts. It's coming from somewhere. Okay, back towards the IC. 2.3 volts. So it's not being sourced from that direction then, is it? One of the schematics is wrong, doesn't match up with the actual circuit. Need to be careful there. And P75 is not going high. That's not the cause. Though it's not relevant to this problem, I do see, while I've been looking in here, some possible dry joints on the rectifier. That all looks a bit dry jointed, so we'll resolder that while we're here. That might explain why on one occasion earlier I switched it on and nothing happened, and I was just mystified as to why the whole thing was dead. Went to do some measurements and then it all started working again. That's probably the soldering on this rectifier. I also don't like the way this capacitor is sitting so close to one of the rectifier pins. That's just dodgy. Let's move that aside slightly. Right, I've isolated R139 so that if we're getting 12 volts from anywhere, or a pull-up voltage from anywhere, I'm guessing 12 volts, we'll see it. So that's 139. Let's have a look now at the top end of R139. That's where we're getting our 12 volts from. I was mistaken earlier, I think, when I thought P75 was not giving us this voltage, but it clearly is. And it's not the eject switch. That's on a different pin. That's on its own special red wire, I think. Okay, so we need to see where P75 goes in the wiring diagram. I also need to resolder some things here. Yes, I'll just resolder the things I've disconnected in this experimentation. Okay, so now if I power the machine up, it will go straight into lace. Like that. Okay, so we need to find out where P75 is, because that's telling the machine to lace. I wonder if that's the clock, because we know we have a defective clock. Yeah, that's a possibility, isn't it? Not terribly clear what connection goes where, but there's a connection 481 on the board, which is that connection that's going high, and the connection 481 on the clock. But exactly which connector does what, it's not clear. But what I'm going to do for a minute is just unplug the clock from the machine. And let's see if that stops this problem with it being permanently laced. Right, that's the clock connector, I hope. Goes up the clock there. So let's see now how the machine behaves when I power it up. If it unlaces, then that's the problem fixed, as far as the fact that we at least know that the clock is the problem. So let's power it up, unlace, which is correct. However, it won't relace now. Ah. What is that then? Does it need that clock in order to be able to lace when I switch it on? In order to be able to switch on? Okay, I've plugged it back in. When I power up, it goes straight into laced. And won't switch off. And if I reapply power, it stays laced up. Unless I unplug the clock. So we can't just unplug the clock and ignore the problem, because that'll make it unlace and stay unlaced. So I'll switch it on now, unlace. But it's ignoring that switch. So we need to work on the clock. I never realised the clock was so important before. Right, we've got to take the front off, and I've got a feeling there's a screw in here which could make it a bit tricky. But let's see what happens. Okay, where's the screw that I need to get to in here? Behind the record button, okay. And a lot of dust. Okay, I've only got limited access to the front panel due to the amount of connectors on it. Let's get this clock off here. Now, one problem we have here is there's no chance of, I don't think there's any chance of using a clock from a 1700, because one of the enhancements on the 1702 was a better clock. It's got more timer settings, I think, so I don't think it's going to be compatible. So we have the clock module out, and we're going to be fairly sure that the main IC here is dead, which is a nuisance. Right, I've got the clock out. I'm just going to measure a few things. How's about the input voltage on D14, which is red wire? That's logical. Should be about 12 volts something. Yeah. And we should get this, we're seeing this spurious voltage on pin 3, which is D13, which is this thing that's making it go laced. Okay, 6 volts now because it's got a load on it again. Because it's been fed by a 2.2k resistor. So that's what we need to chase back, but I don't think we're going to get anywhere because I think it's just going to be a duff main IC, but we'll chase it back. So in normal operation it should be low, it says, on IC 322 pins 10 and 11. That'll be this one. Right, could somebody hold this for me while I switch it on? Oh dear. Could use a hand. 14, 13, 12, 11. Yeah, that's high. That's high. It's supposed to be low. And it's probably because pin 8, which is supposed to be low, is probably high. And that's probably because the main chip's dead. So that's the input. Yeah, it's high. So what can we do? Well, we could just disconnect that input, I guess. We could just isolate that input from this little AND gate. Been used as a buffer. And hopefully that would allow the machine to work. So let's spring pin 8 of that IC. And then let's not spring that. Let's spring instead pin 26 of this, and that will allow the pull down resistor to work. Yes, let's do that. 21, 22, 23, 24, 25 and 26 which has a test pad on it. So this is our timer. So we need to isolate that, either cut the track or desolder the IC at that point. I decided to cut the track because isolating the pin could cause problems if it manages to make contact again. So hopefully now we'll find that the machine unlaces but can be relaced with the power button, which is there. Let's give it a whirl, shall we? Unlaced. No, it's not switching back on again. It doesn't use that switch output, does it? Even when we're not using the timer. Oh, does it really? Yes, I think it does. I think it does. So the input from on D15 goes high when you're requesting it to switch on. D15, let's prove that. Let's measure the voltage on that pin when I request on here. So it's low, I request on. I'm not seeing anything. Well, I'm mystified as to why we're not getting the request to switch on signal from this switch out to the clock. And it may be that somebody's tried to repair it when the problem was that it kept lacing, and they've fiddled about with that switch, is always a possibility. So I'll have to investigate that switch. But in the meantime, what I have proven is that isolating the on output of this IC is not going to fix our problem, because that is also used in association with this button. So we really have to either re-engineer something here or replace the whole clock unit or chip. Well, it won't get a chip. So that's a bit awkward, isn't it? Oh well, let's re-solder that connection. It'll go back into lace, and then we need to investigate this switch and see why that's not working. And I'm going to have to try and get hold of another clock or some kind of fancy workaround. Okay, I've reconnected that pin on the IC and plonk the front back together again. So it'll go straight into laced again. We know that. So we need to investigate what's going on with this switch and why that doesn't seem to present a signal out to the clock. So we need to follow the wiring through from that. Okay, it feels like we have two faults. One is on the clock up here, which is permanently forcing it into the laced position. I've disconnected the output from the IC that's forcing that on, so we can just look at the machine without that signal. And the other problem seems to be the flip-flop from the on-off switch. So this start and load switch. That sends signals through to pins 4 and 5 of this flip-flop chip. So if we look at pins 4, 1, 2, 3, 4, switch it on, I think that's the high side, press the button and it goes off, correct? And the other pin being pin 5, no, 7, which is low until I press the button. That's correct. But the output from the flip-flop is on pin 1, and that should flip and flop as I press the button, and it's sitting there at about 2.5 volts. So this is not then providing the signals that then go on to lace the machine correctly. And I don't see any other components here on this flip-flop that could cause that, so I'm going to blame the chip itself. That's CD4027. If I don't have one in my stock, I'll raid one at the scrap machine. Oh, look what I found. Plenty of RS components, 4027s. So we'll fit an IC socket and we'll install one of those in place of IC102, and maybe it will flip and flop. Okay, that's the part desoldered. So we'll put in a socket and fit a new one. Well, I'll clean the board up first actually. Right, let's clean up the board. Right, now observing orientation, we'll fit the IC socket and a new IC. So pin 1 is down. Right, so we can now look at pin 1 of the flip-flop and see if it flips and flops when selected. Fixed. So we still have a fault in the clock circuit, that the chip in there is outputting a laced on signal at all times, and we can't fix that because it's caused by failure of the IC. Unless we can get hold of a replacement clock module, we'll just have to go with no clock for the time being. But with the output from that feeding another IC, just an AND gate which is acting as a buffer, with that disconnected, it's no longer forcing us into the laced position. We've now fixed down here the flip-flop which operates with the on-off switch, so that that now is requesting lacing when it should. So that was this. It's a bit of a coincidence, isn't it, that we had two faults directly related to the lacing circuit, both caused by faulty ICs. It seems unlikely, but given the age of the machine and that chips can fail, you know, that's what's happened. That's really, it took some thinking to work out that we had two unrelated faults there, both affecting the same circuit. It just seems unlikely, but sometimes you have to think of the impossible. Right, things we still need to do. I've got to refit the clock module, even though it doesn't work. I'll refit it to the front until maybe we can get a replacement. Now we need to fit the video output and of course audio output. There's an audio output signal already available in the machine, but the video signal in there that feeds its modulator needs to be buffered by this circuit, and then it'll go out via BNC socket at the back. So I'll install that, and then I think we've got a little bit of cleaning up of the mechanism to do, a little bit of the tape path, and we should be pretty much done then. You will have seen me fit AV output sockets to these machines before, so I won't cover it again, but basically I've fitted audio and video connectors here, a little bit of hot melt glue on the inside to stop these from spinning around when you put your plug on, so they go through to the this board here. I have blank PCBs for sale, I've mentioned that before, and that connects up to here, so we've got 12 volt feed and audio going straight out to the audio socket and video feed going off to this board. So that will give us the composite video connection. You can configure these for S-video, but that's not the way I use them, just because I tend to connect these to digital time-based correctors like that one you can just about see, which has a digital comb filter, and it does such a good job that I find it gives a better result actually than the S-video, personally, I think. This does have an LED on it. I find it handy just to confirm that you've got it connected up properly, so we'll just test that. Switch the machine on, power it on, good. Stays on for a while after we've switched it off. So we'll hook that up, make sure that's working, then adjust the gain on this to get the picture about right, and then we can see if there's anything else still wrong with the machine. Okay, so we've set that to video input mode on the TV. Now it's working. May need to... I've not got the tracking control properly set. I can't adjust the tracking, so I've messed that up. I'll eyeball the brightness, the gain level on here. It's about right. Ballpark it for now. But yeah, I need to fix the tracking, so I'll just take it apart and fix that. Whoops. I've just set it into the laced position so that I can get good access to the lower drum and clean that surface off, and it's a lot of grot coming off that. This is my second stick already. All this has come off the lower drum, so it really did need a good clean. Keeping these cotton buds well away from the head tips, of course, because they could certainly smash up the head tips. Wow, really, really contaminated that lower drum. So I think it'll play a lot better for having been cleaned up. Right, I'll partly unlace it. Get better access to that part. I'm taking this opportunity also to clean up some of the drive surfaces, just so that everything works properly on the spools. It's a little bit squeaky to take up. Don't know why. Hopefully there's enough torque though. Oh dear. This is a thing that can happen with this format. Earlier on when we were working on this machine, we had allowed this to happen when the mechanism wasn't set up properly. That the tape from the top spool droops into the path of the bottom spool and gets all tangled up. So we need to disentangle this mess and wind it all properly onto its respective spools and reassemble the cassette. This was something of a failing of the format, really, that this could happen. You know, if you were going to design a video cassette format, I don't think, with hindsight, you would put one spool on top of the other. Okay, hopefully the cassette is now in good order. Let's rewind the tape. Sounds good. Shame there's nothing from the clock. Okay, that's rewind. That's going well. Let's stop it. Fast forward. Not so much. Though that could be the tape. They often go sticky in forward direction. Let's check that play works properly. Yep, it's winding properly. Okay. I'll rewind the tape some more and we'll do some tests. Just selected fast forward a bit further on in the tape or further back in the tape, and that is winding just fine in the forward direction as well, so nothing wrong with that. Okay, just playing a bit of tape. The tracking seems pretty central. I can go off that way. There's the center point and go off that way, but it's fairly central. It's working quite well. And that's just one random tape. I could try different tapes. But that is a working N1702. I quite like that. There's also no horizontal shimmer I can see, so both this machine and the machine that made the recording had clean heads. The trouble is, I think if the head gets dirty, it can slow on its rotation. Every rotation, it causes a horizontal shimmer. I mean, you could sit here and watch that program. That's really not bad. Another thing I wanted to test was this eject button. Good, because I've had that fail on other machines. Maybe I can source a replacement clock module in the future to finish this machine off nicely. But the machine runs good as it is. I hope you've enjoyed us working on this Philips N1702 video recorder. I'll do plenty more content on audio and video technology in the near future. Bye for now. Right, that N1702 has used up the last of my populated video output buffer boards. So I'll have to make up another one. I've got all the parts here I need for that. Actually, these have been made with a groove along the top here. So you can snap off the top section if you don't want the chroma part and you're going to operate it is composite video rather than S-video mode. These were originally designed, the circuit was designed by Stefan Heimers, and the PCB layout was Wacker, and I've had a little bit of input on both adjusting the circuit slightly and the PCB layout. We still have a few more boards here. I can sell a few more of these if you don't want to have to go off and get your own manufacturer from PCBWay or elsewhere. I can probably sell about another 10 of those. Right, so if you're into these kind of video recorders, you might find those handy.